Hello learners, I am Dr. Arun Kumar, faculty member, School of Management, Shastra Deemed University. In this session, I am going to talk about one-way ANOVA, analysis of variance. Okay, we will look into more contextual example. I will try to demonstrate very clearly so that you will understand in a better sense. So, what is a one-way ANOVA? You can see I have given here the meaning. Clearly compare means of two or more levels of independent variables. So, if you are able to compare the means of two or more independent variable, then in that situation you apply one-way ANOVA. I'll give you an example. Like, for example, income of the customers, okay, and the purchase behavior. Definitely, the person who is earning higher income with that of the person who is earning lower income will have differences in their purchase behavior. Am I right? So, similarly, there are many contexts in businesses which we would like to know the differences, whether they exist or not. In that context, we will apply to compare the means of the sample population, and we'll try to find out the differences, significant differences exist between the groups. So in this one-way ANOVA, we need one independent variable and one dependent variable. So here the purchase behavior is the independent variable, dependent variable. And when you look at the different income groups, which become the independent variable. The basic test uses is F distribution. You can see here, I have given here. So comparing means is a special case of a kind of regression analysis. So you can see here, I have given in a very conceptual framework, the partition of the total sum of squares of deviations. So the total sum of squares of deviation of dependent variable, that of the independent variables, right? We have independent variable group 1, group 2, group 3, and also there is an amount of error associated with analysis of variance. So when you look at the one-way ANOVA, you can see the research design here between subject design. Different individuals are assigned to different groups. So in one-way ANOVA, which what I am going to teach now is that the presentation which I am focusing is on only between subject. So when you look at the one-way ANOVA, you can see here the data considerations are given here. So the independent variable should be a factor variable, that is, it should be a categorical variable, and dependent variable should be a quantitative variable, that is interval level of measurement, which I am going to demonstrate right now. So there are certain assumptions involved in one-way ANOVA. This is in case of independent, each group is an independent random sample from a normal population. Okay, and normality, I hope you all know what is normality. It is analysis of variance is robust to, you can see here, departure from normality, although the data should be symmetric. Okay, so normality in the sense the data should be normally distributed. Okay, that's the assumption we would expect before we do analysis of variance. Next one, homogeneity. The group should come up from the population with equal variance. That's the condition we need to fulfill in order to execute one-way ANOVA. Okay. So now I am going to clearly demonstrate the application of one-way ANOVA using SPSS software. Hello learners. Now I am going to demonstrate how to apply, in the real situation, this analysis of variance, what we call ANOVA. So you can see here the, before we do analysis of variance, you need to formulate hypothesis based on your research questions, research objectives, and you have to derive from your problem statement. In my earlier chapters, you know how to articulate that, the process of formulating hypothesis. Here in this contextual example, I talked about there is no significant differences observed between, because this context, research has been undertaken among MBA students about the perception of flipped classroom and Bloom's taxonomy. So in that context, I have formulated a hypothesis whether there is a significant differences observed between MBA students' specialization. That is, each specialization will have different perception about the Bloom's taxonomy. I mean, flipped plus revised Bloom's taxonomy way of learning or not. I want to get the perception among different specialization groups. I mean, MBA students specialization groups. So that's the study is all about. In that, I want to see the significant differences observed between the different specializations among the MBA student. So in that, what happened? I just got this output. I'll tell you how to get this output, all that, using SPSS software. So you can see there, once you, there are certain instructions I'm going to give you about executing the SPSS software. That you get the first table called ANOVA. So you see this value, significance value, which is lesser than 0.05. If you have lesser than 0.05, so as I said, this significance value should be lesser than 0.05. So we observe it's 0.003. So what we have to conclude from this output, that you see, so we need to reject the null hypothesis and accept the alternative hypothesis. Once we accept the alternative hypothesis, we have to write inference that there is a significant differences observed between MBA student specialization with that of overall specializations towards the integrated, flipped, and revised Bloom's taxonomy way of learning. So there is a difference. Okay. So that's what we try to infer from this output table. At the same time, we also go for Banforoni test, it is called, and one more Tucky test we use it for understanding which group differs. We have to find out which specialization group have the difference, perceptual differences about the overall satisfaction towards this flipped classroom approach. So in that context, we can see that you see here the significance level. The significance level is 0.030. So there is a differences exist between HR and production specialization. So HR will have a different perception about the Bloom's, flipped and Bloom's taxonomy approach, and similarly, production group will have a different, perceptual observations. So from this, we can conclude that there is the alternative hypothesis already we have accepted it, and we claim that there is a significant differences observed between the different specialization groups, and using Banforoni test, we confirm that there is a difference which exists between HR and production. You can see this asterisk mark here. I think you can see this here, and also you can see this significance level which is below 0.05. So this table will be very useful. And similarly, how to get this output, let me demonstrate right now using SPSS. First you go to analyze, next one you go to compare means. I think this SPSS software students version in Google, if you from IBM, you can download. It is free for 1 month trial period. You can explore this and by downloading this, and whatever I am giving you instruction, you can follow and learn out of your practical doing. So compare means and click one-way ANOVA, since we are learning one-way ANOVA here. And this is the specialization here. Okay, we can see here the specialization. So like this, we can take different kinds of specialization. So I have taken this specialization from here. See, from here I am taking it to here, and similarly this one already here, overall satisfaction towards flipped classroom and revised Bloom's to taxonomy. So I am just taking this one dependent variable here. So then I click post-hoc test. Then in that I am clicking Taki test. Then giving continue. I hit continue. Next one is I just press OK. So you get the output. You can see the output. It is significant, which is lesser than 0.05, and and also you will get the output table as we discussed right now. So this is the way we need to execute one-way ANOVA. So it's very simple. So again, I'm telling you, analyze, go to compare means, one-way ANOVA, put overall satisfaction here and put specialization here, and then try to hit OK button. Okay, so you'll hit the OK button, you'll get this output like this. Okay. So each data will have different observations. So you can see this output. Since we have hit the Taki test, you will get the output like this. So from there you can see this similar output. I just cut and paste the output from SPSS. So I put here. So this one you can observe that since this, if you look at the significance column, it is 0.030, which is lesser than 0.05, and that's why we claim there is a difference between two specialization, HR and production. Already you get the first output. From there we have put here observed 0.003, which is lesser than 0.05, hence we reject. This is the null hypothesis H0. We reject it and accept the alternative hypothesis and conclude that there is a significant differences exist between different specialization group on the perception about flipped and revised Bloom's taxonomy way of learning. Okay. Hope learners, dear learners, you have learned one-way ANOVA, and you can also see the interpretation I have given. You can Google it to get a better interpretation. I'm displaying here this interpretation. So if you look at this interpretation, it is inferred that in one-way ANOVA, the total variation is partitioned into two components. Between groups represents a variation of the group means around the overall mean, and within group represents the variability of the individual score around the respective group means. Significance indicate the significance level of F test. We saw 0.003. Small significance value of I think we got it 0.03, which is lesser than 0.05, indicates group differences between two variables, namely MBA student specialization with that of overall specialization with integrated flipped classroom as Bloom's taxonomy way of learning. Since the significance value is less than 0.05, we reject the null hypothesis and accept the alternative hypothesis. Hence, it is found that we conclude there is a significant difference observed between MBA student specialization with that of overall specialization. So I think it's very simple. And also using this Benforoni test, you can see which group, specialization differs. I think that this input, I think you guys really learn well, and you can download SPSS software and collect some data sheets are available. You can explore that and learn by yourself. Practice makes a man perfect. Hope you will I strongly believe that you guys will practice more to get reinforcement of this learning. Okay, today's session we saw about analysis of variance. We are trying to find out the group differences between the groups. So I have given you an example, purchase behavior with that of income groups. So how a purchase behavior varies among consumers with that of the income groups. Different income groups will behave in a different way of purchase, isn't it? So that's why if you want to really find out the differences between the purchase behavior, you need to go for analysis of variance, and there are many contexts whereby you can use analysis of variance in business. Okay, so tomorrow you become a manager, or you are a manager. If you are working as a manager, make sure that this conceptual learning you can apply and make informed decisions in your company. Thank you so much. Hello learners, I am Dr. Arun Kumar, faculty member, School of Management, Shastra team, the university. In this session, we're going to talk about correlation analysis. So what is correlation analysis? See, in our last classes, we have dealt with the inferential test to examine the differences between groups. In this session, we also look at inferential test used to examine the relationship between variables. Earlier, classes we saw t-test and ANOVA, and now we look at how I want to examine the relationship between the variable using either I can use correlation analysis or regression analysis. I just give you a context. For example, if you want to really understand, there exists a correlation between service quality and customer satisfaction, then you can employ this correlation analysis. You can collect data from the customers, you can evaluate the service quality variables. At the same time, you can also take the feedback about the customer satisfaction, and you try to find out the relationship between these two, whether it is having correlation or not. This is a business context whereby, in businesses we can employ correlation. Like this, there are many contexts whereby there is a huge scope for this analysis. So that as being a manager, for example, if you are a restaurant manager, you want to evaluate the service quality and customer satisfaction. In fact, you want to know, is there any relationship between service loyalty as a restaurant manager? In that context, you can employ this correlation analysis. So, in a nutshell, the definition states that correlation analysis, you can see this definition I have put here. Correlation analysis is used to examine the relationship between quantitative variables, which is measured using either, in our context, we can measure through using Likert scale or through categorical variables. In other words, it's a measure of how things are related. I have quoted an example of that also. So how the variables, the independent variables are related, we can check using this correlation analysis. So correlation analysis are very useful because if you can find out variables relate to one another, you can make predictions about the future, isn't it? The correlation coefficient measures the extent to which variables. So a correlation coefficient measures the extent to which two variables and tend to change together, as I was mentioning in service quality as well as in customer satisfaction, or between customer satisfaction and service loyalty. The coefficient describes both the strength and direction of relationship. You see, in correlation we have, you can find out the strength of relationship starting from weaker relationship or moderate relationship, or looking at the stronger relationship by looking at the R value. In correlation analysis, we'll see a little bit later on that, and also the direction of relationship, like whether it is a positive relationship or whether it is a negative relationship. So we can find out using this correlation analysis. And for example, IQ score and exam score, okay, income and job satisfaction, gender and preferred magazine, cholesterol level and blood pressure, years of education and salary. All these are the context or the examples whereby you can find out the correlation between these two independent variables. And now let's look at the Pearson correlation analysis. Pearson correlation analysis is used to examine the relationship between two or more quantitative or numerical variables. So, for example, if they are related, we want to know how much is that related. I was telling you about whether it is a weaker, moderate, or stronger relationship, and also to find out what direction of relationship. Okay. If service quality improves, naturally what happens? Customer satisfaction level also improves. So that we call it as positive correlation. If an employee is getting demotivated, and definitely the performance will also will go down, isn't it? So that is a positive relationship. And there are certain situations, if stress increases, the productivity level of the employees goes down. So that's the negative relationship we talk about. So these are the mathematical statistical formula to understand covariance. We can determine whether one variable is related to another by seeing whether the scores of the two variables co-vary or not, whether they vary together. This is what we call the covariance. Consider the covariance of x and y. X and y are positively correlated, that is one probability, and x and y are inversely correlated. Sometimes there is no correlation, x and y are independent. So you can, for using this covariance, you can find out the covariance of this x and y factor. You have this statistical working here. Okay, and this is the x column, this is the y, and we try to find out the mean, and we try to minus that, and employing this formula you get this answer. Okay, so what is this R value? Correlation coefficient is the statistical index of the degree to which two variables are associated or related. So by looking at the R value, you can look at the strength, as well as you can look at the whether it is positive or negative by looking at the signs which is associated with the R value. So this is very important. Pearson correlation coefficient is standardized coefficient. Next one is the R value. The Pearson correlation tells you the strength as well as the direction of relationship between these two quantitative or numerical variables you mentioned earlier. So we can formulate hypotheses like there is no relationship. There is a relationship, as I was mentioning. There is a relationship between service quality and customer satisfaction. There is no relationship between service quality and customer satisfaction, which we call it as null hypothesis. And there is a relationship between service quality and customer satisfaction. That is the alternative hypothesis. If the Pearson correlation value is below 0.05, so what we do here is we reject the null hypothesis and accept. So what it inferred, that is, there is a relationship between service quality and customer satisfaction. Yeah. And these are the interpreting R value. We have a strong correlation, weak correlation, and moderate correlation, and definitely anything near to 1 we have a perfect correlation. So by looking at this, so moderate, weaker, and also stronger relationship we can By looking at the value of R, we can predict that. So we were mentioning, if the value is 0, then there is no correlation. It ranges from minus to plus 1. Plus or minus sign near R value indicates the direction of relationship. If stress increases, what happens? The performance of the employee goes down. So that in that context, definitely you will have a R value with a negative sign. So a correlation of 0 indicates that values are not linearly related. However, it is possible they are related in curvilinear fashion. But in this context, we are very much concerned about linear relationship. So these are the different graphs, scatter plots of correlation example. If R is equal to 1, this one we will get it, and highly positive correlation, you can see how it is, and also the low positive correlation, you can see how it is scattered, and no correlation, you can see that low negative correlation, highly negative correlation, and perfect negative correlation. So we can also look at the direction of a relationship and strength of a relationship. Always a positive correlation, a value of one variable increases, value of the other variable also increases. In the case of service quality increases, naturally what happens? Customer satisfaction also will increases. And similarly, negative correlation, when the stress increases, naturally the productivity comes down. So a value of one variable increases, that is stress increases, and the value of other variable, that is the productivity, decreases. And also we look at the magnitude of the correlation and we see whether it is weaker, moderate or stronger correlation. And also we can look at the direction also of the relationship, as we mentioned. Next one is we talk about the assumptions of correlation analysis, and these assumptions are we should use interval and ratio level scales to measure this, and definitely there should be absence of outliers, and the data should be normally distributed. That's one kind of, and both these independent variables should have a linear relationship. And also we talk about homogeneity. It's nothing but it refers to the distance between the points to that straight line. The shape of the scatter plot should be like tube-like shape. So if the shape is cone-like, then it is not having homogeneity. So here to define homogeneity, nothing but it refers to the distance between the points to that straight line. Okay, so you can Google it and try to get more information. And also I posted study material, you can go through that. This is the diagram for these two conditions. So we have tried to find out the relationship using SPSS analysis. Hope you all know you can download SPSS from students version and you can explore that. And there are two variables given. One is height and distance, and you try to find out the relationship between this height and distance. There is no relationship, and there is a relationship. We have come out with a null hypothesis and alternative hypothesis. When you go to SPSS, you should go to analyze, correlate, and Pearson correlation will come up. So you can see analyze, correlate. There is a bivariate correlations. Put those variables in this box here, and just click OK, and you will find out the output like this. You can see here. So this is there is no negative sign here. So the R value is 0.774. So it is having a stronger correlation between height and jumping distance, and it is very significant also. P-value is lesser than, so we reject the null hypothesis and claims that there is a relationship between height and jumping distance. With that, I think we have taken a lot of inputs about correlation analysis. Please download, SPSS student version, and learn by yourself by using some data sheet and find out the relationship, whether it is positive or negative relationship. Definitely, I think when you become a manager, or if you are a manager, you can employ this, learning of correlation and your day-to-day activities. There may be some situations demands you to apply this correlation analysis, apply that, and make informed decision as a manager. Okay, thank you so much.